Weather is a constant presence in our lives. It is an ever-present force that we often take for granted, yet it plays a crucial role in shaping our daily experiences and long-term plans. It dictates our clothing choices, influences our activities, and even determines whether we can proceed with our plans or need to make adjustments. Weather has the power to affect our moods, making us feel gloomy on a rainy day or cheerful under the bright sun. It can lift our spirits or dampen our enthusiasm. From the gentle breeze that rustles leaves to the powerful storms that command our attention, weather is a force to be reckoned with. It can be both calming and terrifying, a reminder of nature's duality. Weather is a force to be reckoned with. It can bring about serene moments of tranquility or unleash devastating natural disasters that alter landscapes and lives. Understanding the science behind weather empowers us to appreciate its complexities and adapt to its ever-changing nature. Meteorologists and weather scientists work tirelessly to predict and interpret these patterns. Weather, in its essence, is the state of the atmosphere at a particular time and location. It is a snapshot of the atmospheric conditions that can change rapidly or remain stable for extended periods. It encompasses a range of variables including temperature, humidity, precipitation, wind speed, and cloud cover. Each of these elements plays a significant role in defining the weather we experience. These elements interact in intricate ways, creating the dynamic and often unpredictable nature of weather patterns. The interplay between these factors results in the diverse weather phenomena we observe. Our planet's position in the solar system and its own unique characteristics lay the foundation for the weather we experience. The Earth's tilt, its rotation, and its orbit around the Sun are fundamental to the seasons and weather patterns. Its orbit around the Sun, combined with the tilt of its axis, creates the seasons, influencing the length of days and the intensity of sunlight received at different times of the year. The composition of its atmosphere, with layers of gases and varying cloud types, all play crucial roles in shaping our climate and weather patterns. The atmosphere acts as a protective blanket, regulating temperature and weather conditions. By delving into the science of weather, we gain a deeper appreciation for the delicate balance of forces that govern our planet. Scientists study weather data to understand these complex interactions and predict future conditions. From the sun's energy to the movement of air and water, weather is a symphony of interconnected processes that sustain life as we know it. The sun's energy drives the water cycle, influencing weather patterns and climate. Weather is a symphony of interconnected processes that sustain life as we know it. It is a dynamic system that constantly evolves, reminding us of the intricate and beautiful balance that exists in nature. The Earth's journey around the Sun and its own axial tilt are fundamental to understanding the seasons and the variations in weather we experience throughout the year. Our planet's axis is tilted at approximately 23.5 degrees, and this tilt remains constant as Earth orbits the Sun. This axial tilt means that different parts of the Earth receive varying amounts of sunlight throughout the year. During summer in a hemisphere, that hemisphere is tilted towards the Sun, receiving more direct sunlight and experiencing warmer temperatures. Conversely, during winter, the hemisphere is tilted away from the Sun, resulting in less direct sunlight and colder temperatures. The Earth's orbit around the Sun is not a perfect circle but rather an ellipse. This means that the Earth's distance from the Sun varies slightly throughout the year. However, the effect of this elliptical orbit on our seasons is minimal compared to the influence of the Earth's tilt. The combination of the Earth's tilt and its orbit creates the distinct seasons we experience. From the warm, long days of summer to the cold, short days of winter, these seasonal changes have a profound impact on weather patterns, plant and animal life, and human activities. The Earth's atmosphere is a delicate envelope of gases that surrounds our planet, protecting us from the harshness of space and playing a vital role in regulating temperature. The atmosphere is composed primarily of nitrogen and oxygen, with trace amounts of other gases such as carbon dioxide, water vapor, and ozone. One of the most critical functions of the atmosphere is its ability to trap heat from the sun, known as the greenhouse effect. Certain gases in the atmosphere, including carbon dioxide, water vapor, and methane, act like a blanket, absorbing and re-emitting infrared radiation from the Earth's surface. This greenhouse effect is essential for maintaining a habitable temperature on Earth. Without it, our planet would be a frigid and inhospitable place. However, an increase in greenhouse gases due to human activities is enhancing the greenhouse effect, leading to global warming and climate change. The atmosphere also plays a crucial role in distributing heat around the globe. Through the process of convection, warm air rises at the equator and moves towards the poles, while cooler air from the poles sinks and flows towards the equator. This constant circulation of air helps to moderate temperatures and distribute heat energy. Section 4. The air we breathe. Pressure, humidity, and weather. In this section, we will delve into the intricate dance between air pressure, humidity, and the weather patterns that shape our daily lives. The air around us is not just an empty space. It is a dynamic mixture of gases with properties that directly influence our weather. This mixture includes nitrogen, oxygen, carbon dioxide, and trace amounts of other gases, all of which play a role in atmospheric behavior. Air pressure, the weight of the atmosphere pressing down on the Earth's surface, is one of the key factors in weather forecasting. Meteorologists use instruments like barometers to measure this pressure, which helps them predict weather changes. Areas of high pressure are associated with clear skies and calm weather. This is because the high pressure pushes down on the air below, preventing it from rising and forming clouds. High-pressure systems are often referred to as anticyclones and are typically associated with stable and dry conditions. This is because the high pressure pushes down on the air below, preventing it from rising and forming clouds. The descending air in high-pressure areas warms up, which further inhibits cloud formation and leads to clear skies. Conversely, areas of low pressure are associated with cloudy skies and precipitation. Low-pressure systems, or cyclones, are characterized by rising air that cools and condenses, forming clouds and often leading to various forms of precipitation. The low pressure allows air to rise, cool, and condense, forming clouds and potentially leading to rain or snow. This rising air can create dramatic weather events, including thunderstorms and even hurricanes, depending on the conditions. Humidity, the amount of water vapor in the air, also plays a significant role in weather. High humidity levels can make the air feel warmer and more oppressive, while low humidity can make it feel cooler and more comfortable. Warm air can hold more moisture than cold air. This is why tropical regions, which are warm, tend to be more humid, while polar regions, which are cold, are much drier. When warm, humid air rises and cools, the water vapor condenses into tiny droplets, forming clouds. This process is a key component of the water cycle, which is essential for sustaining life on Earth. If these droplets become large and heavy enough, they fall to the ground as precipitation. Precipitation can take many forms, including rain, snow, sleet, and hail, depending on the temperature and atmospheric conditions. The interplay of air pressure, humidity, and temperature creates the wide variety of weather phenomena we experience. These elements are constantly in flux, interacting in complex ways to produce the weather patterns we observe. From sunny skies to thunderstorms, these atmospheric variables are constantly interacting, shaping the weather we see outside our windows. Understanding these interactions helps meteorologists predict weather and allows us to prepare for the various conditions we might face. Section 5. Oceans in Motion, Currents and Climate Control. In this section, we will explore the dynamic and ever-moving nature of our planet's oceans and how they play a pivotal role in maintaining the Earth's climate balance. The Earth's oceans cover over 70% of the planet's surface and play a crucial role in regulating global climate and weather patterns. These vast bodies of water are not just static entities, they are in constant motion, driven by a variety of forces that shape our world. Ocean currents, driven by wind, temperature differences, and the Earth's rotation, act as massive conveyor belts, transporting heat energy around the globe. These currents are essential in maintaining the balance of temperatures across different regions, ensuring that no part of the world becomes too hot or too cold. Warm ocean currents originate near the equator and flow towards the poles, carrying warm water and contributing to milder climates in coastal regions. These currents are like rivers within the ocean, moving vast amounts of warm water to higher latitudes. For example, the Gulf Stream, a powerful warm current in the Atlantic Ocean, moderates the climate of Western Europe, making it significantly warmer than other regions at similar latitudes. Without the Gulf Stream, places like the United Kingdom and Norway would experience much harsher winters. Cold ocean currents, on the other hand, originate near the poles and flow towards the equator, bringing cooler water and contributing to drier climates in coastal regions. These currents help to cool down the equatorial regions, preventing them from becoming unbearably hot. The California Current, a cold current in the Pacific Ocean, is responsible for the cool, foggy conditions often found along the California coastline. This current brings cold water from the north, creating a unique climate that supports diverse marine life and affects local weather patterns. The interaction of warm and cold ocean currents helps to distribute heat energy around the globe, influencing temperature patterns and weather systems. This delicate balance between warm and cold currents is crucial for maintaining the stability of our climate. Changes in ocean currents, such as those caused by El Niño and La Niña events, can have significant impacts on global weather patterns, leading to droughts, floods, and other extreme weather events. These phenomena are a testament to the power of ocean currents in shaping our world's climate and weather. Beyond climate control, ocean currents also play a vital role in supporting marine ecosystems. They transport nutrients and oxygen, which are essential for the survival of marine life. Coral reefs, for instance, thrive in areas where currents bring a steady supply of nutrients. Coastal communities around the world depend on the predictable nature of ocean currents for their livelihoods. Fishing industries, in particular, rely on currents to bring fish to their nets. The health of these currents directly impacts the economic well-being of millions of people. Understanding ocean currents is not just about appreciating their beauty or their role in climate control, it is about recognizing the interconnectedness of our planet's systems, from the smallest plankton to the largest whale, from local weather to global climate, everything is linked by the movement of the oceans. Scientists continue to study ocean currents to better understand their complexities and predict their future behavior. Advanced technologies such as satellite imagery and oceanographic instruments allow researchers to monitor these currents in real time, providing valuable data for climate models and weather forecasts. This research is a global effort, with scientists from different countries collaborating to share knowledge and resources. By working together, we can gain a deeper understanding of the oceans and develop strategies to mitigate the impacts of climate change. Protecting our oceans and their currents is essential for the health of our planet. Conservation efforts aim to preserve marine environments and promote sustainable practices. By safeguarding these vital systems, we ensure a stable climate and a thriving planet for future generations.